And let's see. So right now, you see the .p4d is not associated with the file type. And then go to open with. Then you have to go to more apps. Oops, more apps. And then look for another app on this PC. And then in program files. Go into Pix4D mapper and then down to the executable file. And now it sort of knows. So I'm going to start out here by taking a look at the Lab 3 module stuff I put together. And so again, you know, I showed this pretty briefly on Tuesday, but the Module 3 components, so what are the things we need? Sorry, the Lab 3 components. A little background understanding of Module 3. The Pix4D Lab 3, like that, so straight out of the lab manual, that's an important element of this lab. And then this Lab 3 supplemental, the Green River Project, Urea Study Area checkpoints. And really this is a page that I will develop and is not currently developed. Instead what you're getting is the live walkthrough, which would be a combination of what we did last Thursday and what we're going to do today. And then the Lab 3 knowledge check. So our objectives for the module are to understand the key differences of these points, right? And everything starts from the key points, and that's what we were sort of talking about in class on Tuesday. That's why we're talking about photography. We need crisp, sharp photos. Otherwise, Pix4D is not going to be able to identify any unique pixels in our imagery, and we won't have any key points. If we don't have key points, we won't have automatic tie points. We won't have very many choices to make manual tie points. We won't be able to put our ground control points right in the center of our targets, right, if we have blurry images, and the same with checkpoints. So that's why crisp photography is at the core of everything we're doing if we want to have any sort of accurate geolocation in our project. So hopefully everyone understands these these differences in points. The second learning objective, understand the properties and how to create quality GCPs. Understand the properties of and how to create checkpoints. And that's sort of where we left off on last Thursday. We created those 2 checkpoints. And then understand how geotagging accuracy impacts accuracy reporting in Pix4D. And number 5, understand how to assess georeferencing accuracy using the quality report. Right, and so we're going to answer number 4 through number 5. Right, we don't really have you know, maybe I will play a video. Let me see how long this video is. So I think that from what I can tell, that is a pretty helpful video. And I was just messing around with that ray cloud thing, right? So like for example, if I open, so if you navigate to the report for your checkpoints file, and I don't open it with a PDF because we don't have a PDF license for it. So if I were to like look through here and, you know, the coverage was pretty good for the main area where our checkpoints were, but here we have like a little bit less coverage. So maybe I want to, let's check out these ellipses. And so these are the pre-PPK locations. So what we're going to do today is we're going to take this checkpoints project and we're going to update the geotags of the images with PPK locations. And then we're going to rerun this report so you can do like a visual comparison between the ellipses in here and the ellipses outside or with the PPK locations. And I'm not sure, but I think like these images right in here where there are no ellipses, I think that means it's like really tight. It's really good. But I'm not 100% sure. Here's that magnification that Mark D was talking about, 100 times magnified. So again, this is like something you're going to have to get used to looking at. You know, it's like, oh wow, look at the size of those ellipses. Well, what is the magnification of each of those ellipse sizes? But so let's say I was interested in seeing, like, looking at this area of the project and like what are the tie points in there. So if that area is sort of equivalent to, it's like right around here. So if I turn on my cameras, actually it's easier to like select a point with the cameras off. And so if I just click on one of the points in the sparse cloud, now I turn my cameras on, I can actually see like all the cameras that are tied to that particular point, right? So there's a bunch of them. And they're color-coded. And so it's the computed ray color is green, the marked ray color is orange, and the uncalibrated ray color is red. So hopefully I only have green and orange here. And that's what I'm seeing. I don't see any other color. So that's kind of useful. Again, I think this project is pretty well set up, so there aren't a ton of, there really isn't a ton of analysis to do with this kind of tool. Yeah. So any questions about that? Any questions about anything that was in that video? And what I want to see is like, so here, yeah, and we did look at this, I think, right at the end of class on Thursday. So we have these checkpoints. There's a checkpoint here. So it's an error in meters in the X dimension, the Y dimension, the Z dimension. Right, and what do we say X and Y were? So our mathematical graph, right, X is always our left and right, and Y is going to be our up and down. And so if we have positive values up here, negative values down here, so negative, positive, right? So as we go, negative values of X, positive values of X, positive values of Y, negative values of Y. So that's how much, what is the difference between the, where Pix4D identified that point at being located, and then where we reported as our checkpoint location. Ideally, the checkpoint location represents a more accurate location. So what basically, I mean, the way you can report this is you can say, well, my model my model is off by an average of 1.338 meters in the X direction, and about the same, about a little bit less in the Y dimension. It's actually pretty good location in the Z dimension, less than a meter.
Would there be a reason why my quality report didn't generate that session?
Did you save the checkpoints file? Like after you entered the checkpoints, you saved it? Then did you re-optimize? You have to re-optimize after the checkpoints are saved to your project. And then they'll generate the report. So any questions about this? All I really want to do for the rest of our time today is I'm going to walk through basically updating the geotags. So right now, all this accuracy is based on, we have two georeferencing elements in this report, right? We have the geolocation that came from the Wingtra geotags on the RGB61 camera, and then we have these two checkpoints. Right, and what this table is saying is that these checkpoints are not matching up exactly with where AES3040 thinks the model should be according to the geotags. So what we're going to do now is we're going to add the post-processing kinematic geotags to the images and then rerun. We'll re-optimize again with the checkpoints, and we're going to save as, so basically we'll have 4 different quality reports. All right, so we'll have the first quality report, that first 2 of them I ran for you, and that was with the regular geotags, and then I also ran it with the PPK geotags. And those were the 2 quality reports I asked you to grab at the end of class on Thursday. Then we created this report at the end of class Thursday, and now we'll create one more report that has the PPK locations and the checkpoint. And this is what I was getting at. The way I describe it in Lab 3, like I say, you can add checkpoints to your PPK locations, or you can add PPK locations to the file that already has checkpoints. It doesn't really matter how you go about doing it. So the way I describe it, in the notes is the other way than what I'm going to walk you through right now. It doesn't really matter. Both of those reports are going to look the same. All right, are we ready? All right, so do you remember the GCP MTP editors right up here on the top? Well, right next to it is the image properties editor, right? And so if I open that, it's going to open the, this should look very familiar, right? This is the same screen we get every time we're going to add images to Fix4D. So again, what I'm going to do is I'm actually going to go in, and because I can't remember what our GCP coordinate system is, but so if I look in the GCP's folder, oh, it's over there. Trying to make it a little easier for you, Connor. So this is the folder with the GCPs. We have those 3 Excel files, or these CSV files that have our GCPs in them. And then we have 2 files that are called, they have a date of the the collection, the flight, array, RGB 61, so the camera, our 600 foot above ground level altitude with the wing trap, PPK geotags, NAD 83, Pix4D format, right? So we have a Metashape format and a Pix4D format. The information is really similar. It's just the format. I'll just open this up. So the basic information within this file is we have an image name column, right? So that's simply going to match with all the images that are within the project. Then we have a latitude, a longitude, an altitude, and then we have these things called omega phi and kappa. And omega phi and kappa are related to the pitch, yaw, and roll of, so, you know, these are where the aircraft was when the picture was snapped. And the omega phi and kappa basically describes what was the camera doing, right? So if the wind hit the aircraft and it was pitching, so you might have some varying values. And this could be a qualitative check, right? You know, looks like just looking, and I'm not, I don't know what each of these, which one's pitch, yaw, or roll, but you know, if it's a really windy day, we might look in here and see some crazy values, and that could add to some of the uncertainty that Pix4D has with assigning location to some of these images. Right, if it was real windy and the aircraft was crabbing, you know, maybe we would expect to see positive values in one direction and negative values in another. And that's all that's really in here. And so Pix4D wants this particular format, and Chris was nice enough to look it up. And actually the software that comes with the Wingtra aircraft asks you what kind of format you want these geotags exported in. It could be the pitch, yaw, and roll could be a reason why some of those are off.
Interesting how accurate this thing is.
Yeah. Well, yeah, wait till we have the PPK locations. So I know these are in Latin long, just like the original. So it looks like it's the same coordinate system as the original images, right? So we have latitude, longitude, and altitude in meters. So I don't think I need to edit anything here with our with the coordinate system. But what I will do is, so my geolocated images, 563. So what I'm going to do is I'm going to hit this from file next to the geolocation and orientation. All right. So right now it's reading it right off the images, but I'm going to hit from file. So now I'm going to navigate to my GCP folder. I'm going to pick the NAD83, and I don't remember if it went lat long or long lat. But let's see what happens. Okay. All right, so I'm going to hit OK. And really, I didn't see anything change, right? Because if anything would have changed, it would have been probably back here into some of these later digits, right? All the first probably 6 digits, bless you, wouldn't change at all. Because all we're really doing is we're tightening up the location. I'm going to go ahead and I'm going to hit OK. I'm not going to change the coordinate system. It is. And so the the geotags are in a different datum, but I really don't want to, so because when I go in here to edit the coordinate system, it doesn't really give me an option to change the datum. I can change the coordinate system within WGS84 datum, but I don't want to do that right now. Let's just see where these geotags end up. All right, so I'm ready to hit OK. I loaded my Excel file with my geotags. All right, we all ready for me to hit OK? All right, hit OK. So, so what I need to do, nothing's really changed yet, right? So my model's created on the old geotags. So very important next step is I'm going to go project, save as, okay? Right in here, I'm going to have, I'm just going to go in order, okay? So I'm going to save this checkpoints file as, I'm going to save this checkpoints-ppk floats. And you can spell it out. You don't have to use code words. LOCS. You can spell it out. It's fine. Yeah, get crazy if you want to. And you could even add today's date if you really want to. All right, so I've added the geotags. I've saved my project as. So the next step really is to reoptimize. And so this is something I want to point out. So you can, at the top, there's reoptimize, and then there's also rematch and reoptimize. All right, and if I like, so we have a couple of uncalibrated cameras over here on the tail or the nose, whichever way the amoeba's facing. But it's I know it's not going to happen because I just know the quality of the data, but it could be that updating the geotags, would allow you to have these images be calibrated, right? So if that was the case, I could hit rematch and recalibrate, but I'm not going to do that just because it's rematch and optimize. I'm just going to hit reoptimize. Okay. Before I do that, I'm going to open up my processing window, my log output, and my output status. And then I'm going to do it. Okay, you guys ready? Yes. Of course, the only thing that was done so far was this optimization. And I don't know if you guys if you looked at this output status window, it's kind of fun. It's kind of tacky. It's not really, doesn't give you anything new, but. Oh yeah?
It's a processing options.
Looks like it is done. Step one is done. Interesting. Did you go check mark? Can you expand that down? Yeah. Huh. And you did hit,
You have to click advance, maybe that's why. It was checked on your.
Oh.
Maybe that's why. So should I try to re-optimize it?
nah. I mean, it's just like, this is useful, like if you're running all 3 steps with a big model and you want to like know, should I stay up for another hour to see the process, or can I go to bed because it's going to run all night? And that's where this thing can be useful. When you're just re-optimizing, it's sort of gimmicky. It's not giving you a whole lot. All right, so that was it. So now if I go to my quality report, so I go into my MDGR project, I go into the Pix4D folder, and I have my MDGR, Array, Flight 34 checkpoints, PPK locations with today's date. Go in there, go under initial. Oh, I haven't generated my report yet. So I'm going to go process, generate quality report. And that is going to take a while, right? Because it is looking at the new locations. It's building all those diagrams that Mark B was talking about, right? With the ellipses and those lines that show you like how many key points are overlapping within adjacent images. So it has to build all those graphics and put them into the processing report. What is the little model show for this? Oh, I thought it was running the quality report the first time, but apparently it wasn't. Oh, anyone go anywhere fun for spring break? Nice. Where are you going to Mesa or? Okay. Oh yeah, the best. Oh wow, cool, awesome. I got Flying on them? Yeah, like. Are you have a side hustle you work on?
I'm a ride supervisor over the dealership, so that's my summer gig.
Oh wow, cool. That's probably fun.
Yeah, we were doing the evacuation training. Preparing for the scenario of what happens if the ride gets stuck and we could get everybody out.
Mm-hmm. Has that happened in AES? Yeah.
Oh yeah. Especially with the flying coaster. we had a in I think this was 2022 when this happened. Yeah, it was a rainy day. Went in, it's like, oh yeah, there's no one here in the park. Everything's just fine today. We had a power outage happen, and every single ride in the park broke down all at once.
That was when that happened to the roller coasters that had like the Mind Racers. Did it like stop in the middle, or did the rides actually finish?
Well, for the roller coasters, if it's off the lift hill, it's just
Right.
So it would just continue going through the rest of the
Go up and like going backward.
No, it finishes the course as normal, and then it just hits the next set of brakes, and then it just stops at those brakes.
So you have a car crash usually if you guys can't pull the car into the station though?
We have these things called block zones that we have to prevent that whole thing from happening. Okay. But basically, like certain sections of rides of the coaster track where there's brakes at the end of it, where you can say, where the ride can see, oh, there's a train in the section that's ahead. I should have the train stop here, so we don't, bam, bam, bam.
Nice to know that 90s technology was still active.
Yeah, those are basically all 90s roles.
Oh, yeah.
I have that sheet this week.
You coming up, or you had?
Yeah, it's on Sunday.
Okay,
The
cool.
real fun one
When I
is
did the outfit strategy, that's what
3 hours
we
today.
actually did.
because when the power goes out, it's water
I
stop.
met with him last Sunday,
And then,
but like I was.
best case scenarios are just stuff. Worst case scenario, the boat hit something on the bottom of the room and it flips over.
Wow.
Yeah, that would be a bad day. We don't want that to happen. We have the emergency stops on the right that shut off the pump and turn the operators. You do not touch that button unless you're the good reason to. Because, yeah, you could get some.
Wow, blue, like,
Sure.
the other one's
Yeah. It's the river road, right? The shipwreck falls, the other one, right? That one yourself.
Yeah.
Oh, that's what I
I
was
just thought that.
It's the one with the little, I want to talk about the one with the circle boat.
All the drowned.
Wow, okay.
No, it's
The oranges.
I haven't been there. I haven't been to Europe in about 20 years.
And then
Maybe not that long, but
So,
for sure.
you'll see, so I know they have that, so.
this thing.
Right.
So, water park here, oranges.
No, it's in the dry part there.
Okay.
And I've been just testing it from over now.
Okay. Okay, cool. Awesome, man. That looks amazing, really. Nice job. Yeah, and I'd love to take another look at the class too. But I guess this is it's still generating the quality report. Okay. So let's take a look at the quiz for the knowledge check. And I mean, all we really need is that quality report, and it's really all I wanted. And then just give you all time to work on basically the knowledge check. Wait a second here. Let me go to student view. All right, so these are the objectives that are assessed in the knowledge check. So I did add a couple. So there's really nothing about like assessing the value of checkpoints, because I didn't get that far before I came to lab last Thursday. So
My quality report just finished.
great. Okay. Interesting. Sweet. So let's see. So there are 9 questions. So number 1, select all that apply. Which of the best practices for GCPs are used in the PIX40 Lab 3 exercise? Right, and here's where if you remember when we did that Lab 3 exercise, we looked at those points, and even though the quality of that sparse point cloud was so good, if you look at where those, you have to pull up Lab 3, take a look at those GCPs, and then, so these are all the things that PIX40 says are important for quality GCPs. So basically I'm asking you which of those, which of the best practices do those GCPs halved. So minimum of 3 points, visible in at least 3 images, well distributed across the model, not in a straight line. So you're going to have to pull open that lab 3 to take a look at that or rerun it. And then number 2, and I could zoom in a little bit here. So number 2, true or false, using PPK adjusted locations in the MDGR Uray Flight 3 or 4 area increase the number of calibrated images. All right, so in this, I sort of just talked about that, right? I said, well, if you change from regular locations to PPK locations and then rematched and recalibrated and optimized, it could bring more images in.
So for that question, do we look at the quality report and look at the quality check where it talks about the number of images calibrated that actually went through versus what is there?
Yeah, and that's one way to do it. You also, you can look in the report. So, it shows you the number of uncalibrated images here. So the way you're describing it is probably the smart way to do it, use quality report. You could use the individual Pix4D projects. It shows you how many uncalibrated images there are. And I did provide the folder that I gave you had 2 Pix4D projects already run. The first one was with just the geotags, and the second one was with the PPK geotags. And so we just created a new project with the PPK geotags and quality report and the checkpoints. So you could use either one of those quality reports as long as you're comparing the PPK locations to the non-PPK locations.
I actually have less calibrated images. Okay.
I have the same number.
I went down to from 559 down to 541.
Mine just stands steady at 559.
Let me open this one. Oh yeah, I'll never get that right.
Yeah, so if it did go down for you, then fall.
I think we're all agreeing on false here, Rich.
559 and
If the answer's true, then tell us now, please.
yeah, it didn't change for, I mean, it shouldn't have, so it couldn't, no, they were both 559 out of 563. But they wouldn't have changed because I didn't rematch, I just re-optimized. So it wouldn't have changed, so maybe you hit rematch and optimize?
Process re-optimize.
Well, I don't know what 2 reports you're looking at, but I don't think the number shouldn't have changed unless you hit. So I already have this report. I'm going to hit save, and then I'm going to try that rematch and reoptimize. And I'm just trying to troubleshoot, like, how did you guys get a different number? That's one possibility. So I'll just hit save on this. And now I'll hit rematch and reoptimize and hit go. So I'll let that run. But because I have the same number between the two. And I mean, you know, don't worry about like, I'm not gonna say, oh, you must have screwed something up, you don't get the points. So, because this should be false, but we'll see. We'll see what happens when.
Based on going down, my answer is false as well, so I didn't screw up the answer.
So which statement best describes the impact of the PPK processing on absolute camera location for most of the images? Right, and what would be, like without looking at the answers, what should the PPK locations do to our absolute camera location? So absolute refers to how close does it match to reality? How close does it match the real location on the Earth?
Better than
It should be a PPK location should give you, it should decrease the uncertainty, right?
Yeah. It'd be better.
Right. Yeah. And the more uncertainty we have, more error we have. So there are different ways to phrase this, and if you read any of the AES3040 help stuff on accuracy assessment, they actually talk about how the difference between uncertainty and error. There really isn't necessarily a difference. It's more just like terminology. All right, so true, false, PPK correction increased the median number of key points identified in the project images. So intuitively, should PPK correction impact the number of key points? Right, what is going to impact the number of key points? Image quality, right? So how good is our camera? And all those camera elements that we're going to talk about on Tuesday that are in Module 4. So my shutter speed, my aperture, my ISO, those are going to be the things that are going to impact the number of key points. All right, so number 5, true or false, PPK correct. Wait, no?
5, yeah. Okay. Correction improve the internal camera.
Oh, yeah. PPK correction improved the internal camera. I mean, intuitively, right, you have to know what do I mean by internal camera parameters. That's where you have to look at the quality report. These are all questions out of the quality report, right? So there's a little section in the quality report that talks about internal camera parameters. Right, intuitively, is the PPK going to impact anything as far as internal camera parameters?
Yeah, it's not connected really, like that's a separate thing.
And it happens at a
Yeah, exactly.
You're not going to change it proactively.
Right. The only caution there is that if AES3040 calls something like the pitch, yaw, and roll internal camera parameters, then this actually could.
I mean, it did affect the percent on mine substantially.
Yeah, that's so it actually, yeah,
I went from 0.24% to 5.77%.
Yeah, so I mean that does make sense, right? Because this is like a AES3040 term, internal camera parameters. It isn't like,
Shutter speed.
yeah, it isn't those things that we think about as camera parameters.
So then, if on this, I assume on camera optimization, you want the lowest number possible, right?
For
0.24% is better than 5%.
right, and I think it's like an average, right? Is that it reports as an average across all images?
Relative difference between initial and optimized internal camera.
Yeah.
Where is that at?
At the very top.
Oh, the top, okay.
So yeah, there's the absolute camera position, orientation, uncertainty, and then internal camera parameters. And I mean, it does call it, focal length, and then these things like the principal point X and principal point Y, which really is all related to the camera itself. And this is that camera, this is the model of the camera of the lens, right? It's a combination of the lens and the sensor. And basically everywhere that's white, we have agreement with all of our images. So this is where we get a lot of automatic tie points. And then anything dark is where we're not getting as many automatic tie points or key points, right? So we're seeing, like, you sort of take the zoomed out look, it's like the center of this lens isn't awesome, and then along the edges where we typically have what's called vignetting, we're losing some of our key points in those areas as well. And this is averaged across all the images.
Apparently, Siri's listening to us.
Siri's always listening. That's why I don't use my assistant.
I just upgraded my software to the Apple Intelligence last night, and I'm not sure I'm liking it.
Yeah. Just don't talk about murdering anyone.
Professor Noli has a funny story about Siri hearing him say something along the lines he talked about, like the crime and something like that in class, and it like started calling 911.
Oh, right.
Yeah.
The clip? Yeah, I won't even say it. All right, which of the following statements are true regarding absolute and relative geolocation variance? So PPK correction location, geolocation significantly decrease the errors in X, Y, and Z image locations. I mean, that's what I would expect. Oh, this is multiple answers, so select all that apply, I should have said here. PPK corrected geolocations reduce the mean square error in the Z dimension by more than 5 times more. And then PPK geolocations had an impact on the absolute and relative geolocations. So let me just take this question, because I do want to do a comparison of the two quality reports for a specific question. So I'll pull this off the screen. And so I'm going to look at number 6 and pull this over. And then let me find the other quality report. All right, so on the left-hand side, I have the pre-PPK locations, and on the right-hand side, I have the PPK locations. And I'm looking at absolute versus relative geolocation variance, and I think that's towards the, so absolute geolocation variance, right? And if I want to know more about, you know, what is absolute geolocation variance? Of course, I can hit the question mark, and it goes to this, unfortunately, did it just open? Like, why did it do that? So that's all in the report? No, it opened up. I really hate that it did that. It like closed my report and I can't get back to the report because it wasn't a true URL. All right, so I got to open it again. So little lesson learned, right click on those things if you want to learn more and open in a new tab. I should have known better, okay? So you want to know about geolocation variance. Those little things are awesome. Those little help things. All right, initial. Oh, it's rewriting because I reran this again and I didn't save as yet. But I think it erased my quality report. That's what I'm seeing because it's not here anymore. So when I ran, even though I saved, I didn't. What I should have done is I should have saved as before I. I don't know how this happened.
You opened it in the browser, but you never saved it.
No. I opened it. The only way to open it in the browser is from the actual file. But I don't really know why it deleted my quality report.
It should be there, and you don't need to generate, just do quality report, right?
No, it's not there because I'm looking in the folder. It's not there. Yeah, so I'm, but I'm going to pull this one. So this is the quality report that I provided. And so if I look down here at the, so basically we have, so absolute geolocation variance, I have a mean, I have a sigma, and I have an RMS. So my mean values, like how do my geolocations differ between what Pix4E predicted and where the geolocations were? What is the mean difference between the X, the Y, and the Z? And then what is the actual error? So sigma is basically our square root of the standard deviation, or is the standard deviation the opposite of that? Anyway, there's our sigma, and then our root mean squared error, which is our It's our unsigned error, so we get rid of the negatives or positives. So original geotag locations and PPK locations, right?
You want it close to 0 or negative bad or what?
If there's 0, then the model matches reality perfectly. So the lower the number, the better, right? The lower the number, the less uncertainty. So did the PPK locations reduce the uncertainty in this model? Yes. Like huge, right? By a lot.
4 to 5 times.
Yeah. By 2 orders of magnitude. Right? We have 0.000s, and then we have point first digit. Yeah. So 1 order of magnitude would be 10 times.
Okay.
I just can't see it.
These are both absolute. Yeah. Yep. Sorry. I'm not even using the whiteboard. The only reason I threw it over there is so I'm being lazy. But, and then relative is right below that. And relative is a little bit of a different story. So relative is giving a percentage as opposed to like a meters, right? So relative geolocation. So relative geolocation variance, this table displays the percentage of geolocated, located, and calibrated images with a relative geolocation error between -1 and 1, -2 and 2, and -3 and 3. A high percentage of images with a relative geolocation error lower than -3 or higher than 3 may indicate an incorrect value for the accuracy of the image geolocation given by the user. So our geotags may be in error. Verify the accuracy of the image geolocation, and GCPs need to be adapted. And then this bullet down here says if less than 99.6% of the geolocated and calibrated images have an error between -3 and 3, then geolocation accuracy might be overestimated. All right, so what we're looking at here is this is percentage of the images that fall within these variances, okay? So the tightest variance is -1 to 1, right? So for example, when we see 100% in 2, we're definitely going to have 100% in 3. So in the PPK locations, 99.07% of our images fell within a relative geolocation between -1 and 1 meters. That means most of the images in the X dimension fell within a meter of where Pix4D thought that those images should apply. Right? And so with the non-PPK location, let me just square those up. So, I mean, honestly, PPK didn't do a whole lot for these first 3, and then the mean of the geolocation accuracy in meters. But here's where we can see what the PPK did. Right, so the relative locations, I'm trying to make sense of this, but In the X dimension, the non-PPK locations had a mean geolocation accuracy of 5 meters. And then in the PPK location, it was like 2 centimeters, or is that 20, yeah, 2 centimeters.
I have a question. So if the standard deviation changes, but it's still within the above and below 3 standard deviation, would that be considered like an actual change, or is that not really considered a change?
If the standard deviation changed by greater than 3,
Yeah.
by 3 standard deviations,
Yeah, like if it was more than 3 standard deviations, then it definitely had an impact. But if it's within the 3 standard deviations, would it be considered an impact?
I mean, I would think a change in 1 standard deviation would still be an impact,
Okay.
because basically that would say that some of the images are, your variance is increasing. So some of the images are good and some of them are not good.
Okay. So even though it's like allowed, with the above and below, it's still like a change.
It would be it would be considered a change. So you're looking at the sigma? Is that what you're?
Oh, no, I'm just comparing the two and how drastic the change was between the two and what the actual variance.
Yeah, I mean, I'm not 100% sure why we have zeros down here, right?
Yeah,
So, yeah.
mine's pretty much identical. The V changed a lot.
Yeah, and that's still like, so for the sigma, and I'm sure I'm just not able to pull my shit together right now to realize why, but so, because our sigma really is talking about what is our, how much are the errors different between all the images. And so if we're getting zeros in a relative, so somehow this value is like referencing itself, right? It's using the relative location from the images to compare the accuracy of the image locations. But I mean, I don't see, I guess the only thing I really see as a big difference in the relative is this mean geolocation accuracy in meters, right? So let me see something. So here's where it's getting that value. So we're telling it what the accuracy is. So those relative values are coming right from, so these are the PPK locations. Right, and if you remember, we talked about this last week, because when we pull images in, like if I were to just open a new project, and take your time, it's pretty, just going to call this test real quick. So when I add images, right? It asks me, what is your horizontal accuracy?
5.
So that's where the relative accuracy comes from. Right, so AES3040 is just reading this and it's saying, yeah, your relative accuracy is 5 because that's what it defaults to. That's what it defaults as an accuracy for a UAS. So if we would have made some adjustments when we pulled these images in, if we knew that those locations were more accurate. Now these actually are computed from the Wingtra software. So when Wingtra processes the PPK, it actually gives you an accuracy of each image. That's why we don't have like a 0.2. It's 0.2, 0.02 and some decimals because it's an average across all 559 calibrated images. In fact, I'm kind of curious if I do this. I'm really pushing this video card right here. So this is accuracy in the horizontal. So average of 0.02268, all right, as a horizontal accuracy. And this is the whole, it might be slightly different because this is the whole, this is flights 1 through 6, this average, the 0.0226, and then this is just flights 3 and 4. But it's pretty close to what the reported value. So I guess what I'm saying is that the relative accuracy is really, all AES3040 is doing is it's reporting. It's not really, it's not doing any, it's not checking against anything because the absolute accuracy is going to be determined by the model, by AES3040 itself. For relative is only comparing what you're telling it. All right. Then number 7, PPK correction geolocations reduce the RMSE of all 3 relative geolocation orientation degrees. So relative geolocation variance. Yeah, RMSE is just RMS error. Yeah, I don't see an RMSE under the relative.
There's RMS degree under relative just below.
RMS
Yeah,
degree.
right where your mouse is, the right column, RMS.
Oh yeah, yep, that's right there. Yeah, you're right. RMS degrees. And that's our pitch, yaw, and roll. So, yeah, and I say RMSE for all 3 relative geolocation orientation degrees. And so this is our root mean squared degrees, which is a report of error, but I should have called, yeah, I probably shouldn't have said RMSE. So my guess is that these changed quite a bit. It didn't really change very much.
Right, yeah.
Yeah, actually it got a little worse. So maybe, geolocation. And I think, I mean, what makes sense to me is like, so it's a more accurate location here where we didn't have as accurate information about the pitch yaw and roll. These are all sort of like smeared, so it can't really predict a more accurate location because these values are going to be probably closer to a mean where we would expect a little bit higher of a variance here because these values are going to be more variable based on the actual position of the aircraft. But they're close enough to say that they didn't really change a whole lot. So what is the question? And I mean, I would say false there. Because it's actually, it actually increased some of the RMSE. Number 8, select all that apply. Which of the following statements are true regarding the use of checkpoints in a Pix4D mapper project? So this really doesn't have anything to do with the processing of the checkpoints. It's more just like, what do you know about checkpoints? So does Pix4D automatically know the location of the checkpoints? No. I can create checkpoints through the GCP MTB editor. Just like GCPs, I must link my checkpoints to individual targets. And to see checkpoint accuracy, I must re-optimize my model after creating my checkpoints. And I think, yeah, is this actually this report? Yeah, so, yeah, this report has the checkpoints in it. All right, and then what is the approximate size of the RGB 61 images? Cool. So, yeah, there is, and you have lots of images in your folder, but I also did link the one image in Module 4. So I'm just here to take questions. If you want me to talk through anything else or work through anything else. Yeah.
Number 1. So,
okay.
I know with the videos and everything, we actually did talk about GCP and everything like not being like perfectly like in a line and everything. But then when I looked at it, I mean, it kind of looks like it's in a line. So I don't know if that's something that, like, would I check it off? I mean, it was in a line, but does it matter since they're kind of like away from each other?
Let me see if I right, and so I think those are pretty, like if you look at the whole project area, this is the way I was thinking about it when I made that question.
Okay,
It's like, you know, where do you want your GCPs? I want them, you know, when they show you where to put them, in the examples, they have them all on the outside, not in a straight line. Yeah, and then the GCP tutorial, they put them all in a straight line.
Okay.
So, yeah,
Okay.
that's what I was thinking.
Because it does say in the tutorial not to put them in a straight line, but then they did, so.
Yeah.
The other, just don't select that one, right? Not in a straight line.
Right, they are in a straight line.
I get that, but
Right.
it says
As I
not
say,
to
not
use
to
that
do
in the
Because we would
original.
check that one off.
So on the answer, don't put not in a straight line.
Go ahead and read the answer, or read the question, and then make your
I
selection.
have read the question, but I'm going
Which is
off
the
the.
best practice, don't do that.
Right. Right, so what are all the best practices? Like, what do these points actually do as far as the best practices go? Because the practices I list in that question are all good ones. Right, minimum of 3 points, yes, they did a minimum. Visible in at least 3 images. And this ray cloud thing is kind of cool. I mean, I can go and I can look at, the GCPs and I can see, there's a bunch of images, but I also can do this, I can actually find like one of these points that has the GCPs, and now I can go turn the cameras on and see the actual rays, and it's like, yeah, those things are going to a lot of images. That's pretty awesome. This project was really done well.
So how all the images are kind of like oriented? Does that have to do with like the yard on the page?
Yep, exactly. Yeah, and you can sort of, so you can get an idea about like what were the winds doing, But I think we saw that this was I don't remember what kind of,
Definitely made that a trick question though, good job.
yeah, the DJI FC6310R.
So I actually submitted the lab, and that answer ended up turning out to be incorrect, which is kind of like and the same thing with the well distributed, which.
Yeah, I'm in the same boat.
So you're saying that those are well distributed?
Well, they're not right next to each other.
But if you look at the Pix4D tutorial on
But your question is which of the best practices for GCPs are used in the Pix4D Lab 3 exercise. It's not asking about the tutorial.
Yeah, exactly.
It's asking about how you did it in the lab.
Yeah.
So that's what I went off of by not choosing not in a straight line. They are in a straight line and they are well distributed across the model. The two that we have.
Okay, so and that's what I'm saying is that I'm not asking you to say I'm not asking you what the lab told you. What I'm saying is what is the reality about distributing GCPs, right? And
but that's not what,
all right, just hold on one second because I can't.
You did just say read the question and then when you consider asking about lab 3. Okay, gotcha.
Jesus Christ. Okay, so number and distribution of ground control points. All right, there are a couple things here, and let me go to the Pix4D. And which one has the GCPs? They don't really label these really well, but there's a really good graphic in here for the GCPs. I think it's well, not this one. Because this graphic is helpful, and because I want to just quality assessment, altitude, rate, processing speed. That was the tie points one. Okay. This is a good spatial distribution of GCPs. All right, so the orange box is your region of interest. The GCPs are spread out throughout the study area. If you go into Module 3, I talk about the distribution of GCPs. I actually think I use this graphic in Module 3. So if we look at this project, turn off the camera so we can see the GCPs. Are these GCPs distributed in the study area? I mean, we collected imagery over this entire area. So if the region of interest is this entire study area, I would say this is a really shitty distribution of GCPs. We want to have GCPs on the very outside edges at the very most. And if you read in Module 3, I talk about PPK locations essentially being little GCPs. And as we get away from those locations, our error starts to increase. Now, if our region of interest is just this park, then this might not be a bad distribution of GCPs. So I can, I can't really get in your head about what you're thinking, but when I look at this project, I look at, they collected all this imagery. Why? I assume they collected the imagery because it's part of the project. So this is not a good distribution of GCPs.
Well, what about the straight line one?
I'm understanding as far on it now, because what we had, they were in a straight line, and so.
I think these are in a straight line, right? That was.
With the two, yeah.
No, wait a minute, so yeah, no, okay, so but then we're correct, because on here, by not selecting not in a straight line, it was incorrect, so you were, I feel the answers on here are wrong, but I did select well distributed across the model, that was incorrect, and I did not select not in a straight line, and that was incorrect.
Right, yeah, I worded that way too confusing.
They were in a straight line, which is why I didn't select they were not in a straight line.
I definitely worded that way too confusing,
Yeah.
But
I think the correct answer should be the first three, but you have
Right.
1, 2, and 4s.
there are minimum, they are in at least 3.
They're well distributed across the model, but
They're not.
But they are in a straight line.
Yeah, I wouldn't select either of these last two because they are in a straight line and they are not well distributed, right? Like those were the two best practices, because what I did is that tutorial video I just played, if you play it, Mark D says, make sure your GCPs are not in a straight line. He says those words. And so I guess the GCPs do make that little T. But I mean, I think this is a good discussion of accuracy assessment, right? The accuracy of words and the relative accuracy of the location of these GCPs. Because if we really want to understand good three-dimensional, like if I want to measure the height of these houses, the roof height of these houses down here, these GCPs suck. they are like in, they're pretty much in a straight line. I know these two, they make a little T, but don't worry about, like, I'm not going to mark the point off arguing. And it sounds like maybe I didn't mark the quiz correctly, but
We trust that you'll do the right thing. It does seem off.
but this is what I was looking for the right answer. It's okay. Yeah, don't worry.
Retake it.
Oh, you can't?
No, you can't. It's only once.
Oh, man.
Yeah.
It's
Now that
all
we
fine.
know, can we
It'll be
take
all
it?
right. It'll be okay.
Yeah. He'll fix it. He'll give it to us.
I feel like I understand better. It's just like,
Yeah, and
like it wasn't.
I
Perfect,
understand
but I
what
thought
you
it was
but I also think it's not well distributed across the model because we couldn't use so many of them because we were only going up like 3 rather than all 6 flights. But when looking at it, you actually did have it pretty well distributed across the model. It was just that we could only use 2 of them.
right, but I'm talking about lab 3 here. I'm not talking about
I get it.
the assignment.
I get it.
Okay. Yeah, I mean, that's
Why do we only use the 2?
because the bear attacked the other one.
Oh, yeah, that's right.
And now
I forgot about that.
You left your lunchbox out in Yogi Town again.
Yeah.
And I mean, I do expect that, Module 3 is tied with Lab 3, and that's where I really talked about the distribution of, how to distribute. I don't know, and, it's been 3 years since I taught this class, and I haven't been doing a really good job of describing all the modules. And I look forward to teaching this class again next year when things are a little fresher. But that whole conversation with Ricardo and where to distribute GCPs on top of the parking garage that really addresses this question, or this idea of like well distributed.
That would do like the height differences between like the air conditioner and like the roof and things like that. Like just kind of like trying to get different elevations.
Right. And a couple principles behind distribution, and I think I said this in Module 3, is we want to capture variance, right? And so if that variance is spatial in the XY dimension, or if that variance is spatial in the Z dimension, either way we want to capture that variance with our GCPs. So if we're going to capture spatial distribution in the XY, then I mean I really like what Mark D is showing here. In that video, I have too many windows open to find the video right now, but this one. I like this graphic. Got well spatial distributed, it's like, it's a stupid little polygon with some dots on it. That's a really good, for a flat parking lot, that is a really good distribution. Now, if you have a bunch of topography down in this corner and it's flat everywhere else, well, maybe we need a couple more GCPs over here. And I think I didn't do a really good job of illustrating that in Module 3, even though I did talk about it.
Module 3, just with that map itself, how did those points get determined? Again, why wasn't it spread out? Was it just not good enough, enough overlapping and images in the outer areas?
For like the Pix4D Lab 3?
Yeah.
My guess is they just cared about, they were measuring something in the park,
Okay.
even though they flew the whole HOA or whatever.
So if that's what they care about, then it makes sense that it
Absolutely.
would be
Absolutely.
in there.
Right. Absolutely. But, and I'm making the assumption, if they collected imagery over the whole thing, then why the heck do they only put GCPs themselves?
Yeah.
And that, I mean, that's why I think this is a great discussion, because it is all relative. Like, what's your, you know, if we go back and look at principles of the project, the first principle, defining the project, what is our objective? What do we hope to accomplish with the flights and at the end of this project? You know, if it's relative to the whole HOA, these GCPs suck. If we just care about making sure that we're just making an orthometric map, an orthomosaic map of the park, the GCPs are great and they're fine. And why the hell did you collect GCPs in the first place? Because the geotags are going to do a fine job of putting that map right where it needs to be. Because yeah, all the images are geotagged.
I'll test you on a different day, when it would be, when you make that call and when to use GCPs, when not. But, yeah.
Yeah, I mean, and really, if you're, there's a lot that goes into answering that question. And that's exactly what Ricardo asked. Pretty much, well, I think that's what Ricardo was getting at, right? And he wanted to look at, how, you know, in the 20 years since that parking garage was poured, how, you know, how much has that surface sloped. So I'm trying to pick out an inch or 2 inches across 1,000 feet. It's like, yeah, you're going to need some GCPs out there just to make sure that your model is super accurate. But you need something, you know, what are you comparing it to? I think that would be the only way, would be making some assumptions about how it's built. But yeah, it's gnat's ass stuff to really, you know, if you already have geotags, GCPs are only necessary for like engineering type projects usually.